Hey, welcome. This is Thursday, October 13th. Really, this is just a pre-recorded lesson, but hey, this is day 4. Again, I'm away at OFSA today. Save your questions for Friday. Today we're going to be looking at day 5. So I'm away yesterday and today. But here's your video lesson. You'll get it posted right here. Please make sure the supply teacher is plugging in the USB for any volume. Our test is next Wednesday, and parent teacher interviews is also next Wednesday. All right, you should have day 5 in front of you. If not, press pause and go grab it. Okay, so today we're going to be looking at solving exponential equations. So solving just means like making it equal to 0 and finding x. That's the whole point of solving. It's just what is x. So we've done things like linear, like we move this over. We got 4x is equal to 13 plus 3. So 4x is equal to 16 divided by 4 divided by 4. We get x is equal to 4. Right, or this, right? What do you have to do here? You have to factor it. So what are we looking at here? Two numbers that multiply to give us 48 and add to give us 2, and then just change it to a -2. So we get 6 and 8. Okay, and then how can we get -2? And there's no number in front here, so it's an easy answer. -2 is -8 and +6. So our answers here are x is equal to +8 and x is equal to -6. So that's how we solve quadratic and linear functions. Now we're going to go ahead and solve exponential functions. Well, for exponential functions, all we're doing here is we're trying to figure out like 2 to the power of what is 64. And that's what we're trying to figure out. What is that what? Sometimes it's easy to kind of like guess and check, but other times when we're dealing with fractions, it's not that easy. However, there are some really easy steps to follow in order to kind of figure out how we are solving this. So some key things to remember here is trying to find this common base. So if 2 powers are equal, then they both have the same base. And then therefore, if we had like b to the x is equal to a to the y, and a and b are like the same number, then x and y will be the same thing. All right, so steps, write both sides of the equation with the same base. Okay, we're going to do that right here. So like 2 to the power what is 32. That's all we're looking for. Since the bases are equal, therefore the exponents have to be equal. Like that makes sense. You just plug in some things for x and try to get 64. Okay, just like that. And solve the equation. All right, so we got 2 to the power of x is equal to, well, 2 to the power of what? What's 32? 32 is 2 to the power, and then go on your calculator, 2 to the power of 2. Well, that's not 32. That's 4. All right, 2 to the power. Press pause, go figure it out. Okay, 2 to the power of x is equal to 2 to the power of, hopefully you got it, it's 5. So therefore, x is equal to 5. That's what x has to be. 2 to the power of 5 is 32. Okay, that's all that's saying there. All right. Now, a little fancier. We got 3 to the power of x plus 1 is equal to 81. Again, you can go ahead and try to like guess and check, or just figure out what is 81. 3 to the power of 81. So again, on your calculator, 3 to the power of 2. No, that's 9. Don't try that one. 3 to the power of 3. 3 to the power, oh, did you get it? Yeah, it's 3 to the power of 4. So 81 is 3 to the power of 4. So can you kind of guess what x plus 1 is 4? Yeah, that's all it's saying there is x plus 1 is equal to 4. So it's kind of like we're taking this little value right here is equal to 4, and we're bringing it right there. Okay, since they both have the same bases. So we have x plus 1 is 4. So what's x? What plus 1 is 4? Well, we can either do it the short way, or we can go ahead and try to solve it. So 4 minus 1 is 3. So x is equal to 3. That's right. 3 to the power of 3 plus 1, 3 to the power of 4 is 81. Yeah, we got it. Oh, this is looking fancier now. All right, so can we change 2 to be a 4? No, but can we change 4 to be a 2? Yes. Okay, so we got x to the power of 1 is equal to, what's 4? 4 is 2 to the power of 2. And then we've got an x plus 1. So really make note of this, that the 2 is, the 2 to the power of 4, like this one is here, and then this is in brackets beside the 2. so it's doubling everything here. Okay, so we've got the same bases. We can write this like this right here. So we have x minus 1 is equal to 2x plus 1. So we got x minus 1 is equal to 2x plus 2. That's the important part right here, is seeing that it is doubled. Okay, let's move everything around. I'm going to move x's over here, numbers over here. So we've got negative 1 minus 2 is equal to 2x minus x. So we get negative 3 is equal to x. Awesome, that's it. All right, let's go ahead and try this one. 3 to the power 4x minus 1. Can we change that 3 to a 9? No, but we can change 9 to be a base of 3. Right, this is 3 to the power of 2. Okay, so again, we have the same bases. We can write this all right here. So 4 to the power x minus 1 is equal to 2. 4 to the power of x is equal to 2 plus 1, right? That's going to jump over. So 4 to the power of x is equal to 3. How do you solve for x? Divide by 4. X is equal to 3 over 4. Again, at any time, please press pause. All right, let's go ahead and check out this one. So we've got 4. Can we make this base of 4 into a 16? No, but we can make this 16 to be a base of 4, right? 4 to the power of what is 16? So we got 4 to the power of 5x minus 3, and then 16 can be a base of 4. Right? It's a base of 4 to the power of 2, but this is in brackets, right? All right, so we've got the same basis. We can write this in one line right here. So we've got 5x minus 3 is equal to 2x plus 1. Go ahead and solve that. 5x minus 3 is equal to 2x plus 2. Bring this over here, this over here. 5x minus 2x is equal to 2 plus 3. So we got 5 on this side, 3x on this side. Divide by 3. Again, anytime, please press pause if I'm going too fast. The only reason I'm going fast is because I only have 15-minute blocks per video. All right, so we got it. That's our answer, 5 over 3. Let's go ahead and check this one. Ooh, a fraction. 5 to the power of 2x minus 1 is equal to, can you kind of guess? This is a base of 5, right? How can we make that a base of 5? Well, that's 1 over 5 to the power of 3. Yeah, 5 to the power of 3. Check it. 5 to the power of 3 is 125. All right, is there any way we can make this with just a base? Absolutely. 5 to the power of negative 3. That's it. Okay, now the bases are the same. We can write this in one line. 2 to the x minus 1 is equal to negative 3. So 2 to the x is equal to negative 3 plus 1. 2 to the x is equal to negative 2 divided by negative 2 divided by 2, sorry, is equal to negative 1. And we kind of check that right here. 2 times negative 1 is negative 2. Minus 1 is negative 3. That's 5 to the negative 3. There we go. So you can always I always want you to show your work in case there's any mistakes, so you get marks for that. But you always check it. Go back up. 2 times negative 1 is negative 2, and negative 2 minus 1 is negative 3. And that's 5 to the negative 3. Great, let's go and try this one. So on your calculator, start crunching in some digits, like 4 to the power of, and I'm going to pick 4, right, because that's our base here. 4 to the power of 3. No, that's 64. 4 to the power of 5. Is that it? It's it. So 4x plus 3 is equal to, well, this is 4 to the power of 5. Well, 4 to the power of 5, that's over 1. That's a negative 5. So again, we can go ahead and make those equal to each other. All it's saying is, how do we get negative 5? How do we get negative 5? What plus 3 is negative 5? That's all it's saying. All right, so what plus 3 is negative 5? Bring that 3 over to the other side, becomes a negative. That's negative 8. Okay, and then maybe even this one. Maybe even this one you can kind of solve on your own and figure out, yeah, well, this one's not that bad. So 3 to the power of 3x plus 1. Hey, there's a 3 here, but the bases are the same. What's the exponent right here? Is it 0? No, it's a 1. So 3x plus 1 is equal to 1. 3x is equal to 1 minus 1. 3x is equal to 0. Divide that by 3. Divide by 3. X is 0. Let's check. 3 times 0 is 0 plus 1. is 3 to the power 1, which is 3 to the power 1. All right, for this one, what we're not going to do is we're not going to take the 3 and multiply by the 5. Why? Because the 5 is stuck. It has an x plus 1, so we can't just multiply these together. However, we can change this. So we have 3 to the power of 5x plus 1. We can change 15 to be, well, let's just do this, 5 times 3, right? That's the same thing. And if you have one number that's being multiplied on the other side, and it's the exact same number, we can divide those to reduce them. Actually, they're eliminated. So we have 5x plus 1 is equal to 5 to the power of 1. So x plus 1 is equal to 1. X, putting the 1 over the other side, is 1 minus 1. X is equal to 0. Let's go and check to see if that's true. 0 plus 1 is 1. 3 times 5 is 15. So that's the only way to get rid of this value, to multiply these together, is to input something in for x and solve. So what's happening here is it just changed 15 to be 5 times 3. Whatever you have on one side, you can cancel from the other side because they just reduce off. So it's like they're both divisible by 3, so the 3's can be reduced to just get the 5's. Right over here, we have a base that's being multiplied with the same base. Hey, that should ring a bell. This is a power law. When two bases are the same, we add exponents. Right, so here we have 3 to the power of x plus 2 plus x is equal to, can you make this into a base of 3? Let's go try it. 3 to the power of, okay, it's 3 to the power of 5. So you have 3 to the power of, that's 2x plus 2 is equal to 3 to the power of 5. Let's bring this down now. Since they both have the same bases, all we're trying to do is make this equal to 5. All right, so 2x plus 2 is equal to 5. Let's bring that 2 over the other side. It becomes a negative. 2x is equal to 5 minus 2. So 2x is equal to 3. That means x is equal to 1/2, or sorry, yeah, 1 and 1/2. So 3 divided by 2, 1.5. I'd like you to keep it as a fraction. No decimals. All right, this one. Hey, there's a lot going on here. Can we change this? Maybe you're thinking like change this into like 2 squared, but it's a plus sign. Okay, that doesn't work with plus signs. It works with like multiplying, but that doesn't work. What could we do with that 4? Well, if you guys moved it over, that's exactly what you want to do. Move it over with the 68. Those are friends. 68 and the 4. So 68 minus 4, that gives us 64. That's 2 to the power of something. What's that? 2 to the power of 6. So 2 to the power of x plus 4 is equal to 2 to the power of 6. What plus 4 is 6? Hopefully you got that by now. If not, you can write it down and move that 4 over to get 2. Awesome. That's it for now. If you have any questions, please let me know or ask around. I'll be back Friday. There's a homework pages right here, so make sure you're checking out that homework page, which is right here. All the answers are on the bottom. I'll try some of those tough ones out, and we'll see you on Friday.